Absolutely nobody used this variable. This is stupid variable. Useless. Okay, so this useless is not useless. This useless is actually what is it? Hello everyone, welcome back to the second episode of this series. In the previous episode, we did some reverse engineering to recover important types and data structures. And in this one, we're going to continue with that process. The only difference is that this time, I'll also be working towards getting a POC, or at least a crash. As always, feel free to follow along. You might see me going back and forth as I walk through the details, and it might be confusing, but I guess that's all part of the process. After all, you have to remember that this is a live recording. So, without further ado, let's dive in. Hello again. Today is the second day of this challenge, and it's morning now. And today we're going to continue. I hope we're done with reverse engineering this, and we can start with the second phase, which is try to find vulnerabilities. Basically, yesterday, most of the efforts were dedicated to creating structures, enums, so it will be easier to read the decompilation. As you can see, now the decompilation is filled with arrows and shit. I mean, that's a lot more readable. I still fear from the members of SparkNotes that maybe I got them wrong. For example, here I have an unknown member, and this one I'm not even sure it's ker account, but I guess we'll see. I mean, like every good reverse engineer, I base my names on speculations. So we need to hope that those speculations were right, and if not, I guess we will find out down the road and fix the names or maybe fix the layout and etc. So yeah, now, but before we start to look for vulnerabilities, I want to do a recap, because I feel that still not everything is connected. Let's try this thing. This Miro software. It's like MS Paint, but on steroids. I don't know if I like it. I will try it today. And by the way, shout out to, I don't remember his name. It's this guy. He's a developer, and I saw this tool Miro from his streams. I think his name is Mark. I will leave a link or something, or maybe I will just edit the video and I will add reference to his YouTube channel. Anyway, so we have a node. Oh shit, let's try to think again why I started this. I started this because I wanted to recap everything visually, right? And we almost finished it. We just have, I'm trying to understand what are we missing to complete this recap phase and then continue with the next phase, which is the actual exploitation. And bug hunting. Okay, yeah, it was the all nodes. I was wondering how, like why there is a next edge and all nodes. It makes sense that this would be next edge and then next, and this is how you connect, but why would you have all nodes? How all nodes is related to this thing? If you don't have node info. So not all nodes have node info. Huh. Not all nodes have node info. If you create a node and you never link it, you won't have node info. If you create a node and you link it, still don't have node info. If you create a node and you do get info, you still don't have. Connected nodes. Yeah, I think you can. Oh. Can you link is finalized, is finalized. Curcount is bigger than curcount. Oh. Okay, so this line is responsible for what I just asked. I asked, like, what happens if you connect like A to B and A to C and then A to D. Maybe here, D will be here. But it looks like it's impossible to connect more than two nodes into one node, like two edges to one node. Node one could count, because if you're trying to link between, like, I don't know, A and D, it should work because D is a lot bigger than. Never mind. Is finalized. Okay. Edge. That's where we need to. Connected nodes. 32. And then here, when you finalize it, you Kernel caches. What is that? Okay, that's it. It looks like a pool or something. Yeah. Yeah. Connected nodes. And you traverse through the node. Core index. Mm. Hmm. Node IDX result. Core index. Num edges. Oh, Realog. There it is. Finally. There it is. There it is. You reallocate all nodes 16 times current index because you want to like make some room for the other pointers, and then you take the connected nodes and you connected, like set connected nodes. If it grows, and traversal is called from two. Well, finalize. It's from finalize. Aha. Connected nodes. This is interesting. So start with 2 connected nodes. So it is all nodes. It's not connected nodes. It's all nodes. Num edges 2. So when you reallocate it, where is it? Oh, it's capacity. Can we, like, okay, capacity. Core index. Okay, now so when you finalize something, you traverse through the graph and fill in this array, and also allocate this and populate this, and then fill this array with all the nodes that that are connected to this node. Okay. this one don't have a spark info. And next points this, and then this points. So only when it's finalized, this one would be populated. Okay, I'll be right back. I need a small break. I don't know, just to make a coffee or smoke something. I'll be right back. Okay, I'm back now. I just brought myself something to drink and I ate a small snack. So now we're actually going to recap this whole thing. Like I said, in this example you have two nodes. You have node A and node B. Whenever you open this character device file, the driver will allocate a Spark node object. It won't allocate Spark node info yet. It will just allocate Spark node object. And then we open it again and we'll create a second Spark node object. Now, whenever you link A and B, it will allocate an edge for A and an edge for B. And we'll connect them. Like prev will point to here, and next will point to here, and node pointer will point here, and node pointer will point to this node. After you created your graph, you open, you linked, then you call finalize, and finalize will allocate node info for your wherever your root node begins. Let's say you say finalize A, so it will allocate a node info for A, but there will be no node info for B. Node info is only for the root node. Then it will allocate Spark node info, and it will also allocate an array of pointers that points to all the nodes that that A is related to. Like it will traverse through A and then go to B, etc., etc. And we'll create an array of pointers to all those nodes. So that's the flow. And whenever you're free, okay, whenever you're free, whenever you close the file, you free the node. Like if it's finalized, then do this. But if it's not finalized, if you close it before, let's say you open a node A and then you open a node B and you link them, but you still haven't finalized it yet. So what you would do, you will go here, you will skip that, and you will just free the edges. Free the edges and then free the node. Okay. And what if we like close twice the same file? Would that gonna give us a double free? No, because you use close. Linux won't allow this. Like, it's not that it won't allow this, it just won't work, because once you close a file descriptor in Linux and then you try to close it again, it probably won't be exist anymore. So what if you create A and then create B, link them, close one of them, then it will free, let's say we are closing A. Because it's not finalized yet, we'll skip that and we'll go straight into here, where the edges, it follows the edges. And free them. And then finally, it will free the node. Over this node. So to free this, this, and this. And this will stay allocated. Okay. And okay. And if this stays allocated, well, let's just do it backwards. I'm sorry. We allocate A, we allocate B, we link them, and then instead of freeing A, this is the previous example, let's free B. I'm doing it in reverse because here I have more arrows. So B will be freed, these edge will be freed, and this edge will be freed, but A is never freed. So I know just speculation, but the next E of A will point to a free area, to a free memory region. I don't know, like that's, oh shit. Decompress.sh. I'll just import it from another lab that I have. Yeah, here. If we want to compress, what? And if we want to compress the file system back, we'll need another script. Yeah. Okay. Hacks. Let's just make sure it works. Oh no. Now we're doing decompress. Good. Yeah, we have the flag. No, I'm just kidding. This is the kernel module. Okay, now let's take hacks and say, just to make sure that this is our program, compress and then run. Okay, that's cool. Okay, compress. Where is it? Hacks. Okay, compress, run, and it should be in our home directory now. Nice. Okay, demo. Okay. What about the timing? They had like a weird timing in it. Timeout. T. I think it's I'm sorry. Forgive me for my cursed CTF tactics. Now, so we said we are going to link nodes, node A to B. The weight doesn't really matter, but we'll keep it 4. And then we will link, no, we don't need to link it anymore. We don't need to. And link nodes. Wait a minute, maybe there's a bug in query. What happens if you allocate 1, allocate 2, link them, and then free that one, and then you query this? What would happen? Get info, no, query, and if node info. but node info doesn't exist. Node info exists only when you finalize something. So you will skip all that. Oh, and that's free. So you'll just hit the same flow. Okay. So if we link nodes 0 and 1, let's change n to, oh, shit. Okay. To 3, and then we will query, we link 0 and 1, and then we will close 1, which is B, and then we will query 0 to 1. Now, because node A is not finalized, free the node and its edges. Because node A is not finalized, this will go to less. I think. And we don't need this. Okay. Compress and then run. Oh shit, line 45. No, query returned something else. Is it returning early? Like, are we? Oh. Oh, no, 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 we're closing one. Stupid. I close like what? One is like STD in or STD out. Okay. Hawks. Okay, why there's no crash? B node. Free the node and its edges. Wait a minute. Oh, okay. It's IDX and IDX. That's FD1. Then query 0 to 1. And it's finding the shortest path between A and B. This is supposed to trigger node info. There is no node info. So it will jump here. This will be the return code, and then wait a minute. Yeah. It continues here unconditionally. Continue here. Okay, let's just try to oh, wait, you query. This will go to why are like double free? Why are we trying to hit free twice? This is how we're hitting free one time, and then oh, now it, I think it will crash. Private data of the currently opened file. FD0. It will always FD0, it will always try from here. What are you doing? 0, 1, 0, 2, 1, 2. And when you query, you're starting from 0, so it's okay. I don't understand why my code, because node A is not finalized, should go to Spark. Free the node and its edges. Okay, what happens if we close it? We close and then we finalize. Around SH. Oh, what is this? General protection fault. Blah 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 blah. Okay. Because I don't understand, like these and these are supposed to have the same effect. I really don't understand. Maybe like close. Maybe because when we are closing this file descriptor and then we are trying to open it, like to query, to put it as part of a query, we are fget. Yeah, this is not a valid file descriptor, but still. That's fucking weird. Anyway, we found a bug, but still, it's in traversal. I mean, the bug is not in traversal. It's like in. It's in close. When you close it, you're not. I don't know, like cleaning the pointer or something. Yes, you iterate through the edges, but you are not setting 0 instead of the pointer. And the second part of this bug is at where is it? Finalize. Yeah, finalize. You assume that yeah, you were hitting this function. And you reach here, and then you're calling traversal again. And then you're doing mutex lock, which is here. And the node pointer, it's invalid, so yeah, because yeah, you're trying to finalize that, and this is freed. Yeah, so you go to the next edge, you go here, and then the next edge will tell you to go to node pointer. If it's finalized, then you do unlock. But if it's not finalized, then you would set it to be finalized, and you will call traversal on node pointer with node info. I'm just entering like an infinite loop here without understanding anything. It looks like it's just like that. Let's just go like that. It should go from here to here to here to here. Unless next E points to that. That's what I'm thinking. Let's look at link one more time. We have node 1 and node 2. You're allocating an edge. New edge. New edge. Next. And the new edge should point to node 2. Oh! What? Edge. Can we leak the stack? Where's RSP? Oh, there it is. Okay. This is RBP and RSP. Huh. So if we forge a I don't know, let's say we can leak this. Put this in the message. What? Okay. Oh, it's there. The message. This is always the same, like 7E00. No, it's not the same. Wow, this is even slower than I thought. Like, why my brain is not working? Like, what? What? I mean, yes. This is a use after free, but how can we leverage this into type confusion? Okay. What about the weight? We can control the weight. Maybe somebody's using it somehow. Like who's using Edge? Spark Edge. Finalize use it. But I don't know if I want to deal with this weird recursion when I leverage this primitive capacity. Okay. What about the query? Okay. Why would you use that? V13. And then next wait. What? And then you put in here a pointer. What is this weird? It needs to find the shortest path, right? So you take all nodes between SRC to DST. So you take this. What? You take the weight? Probably not a pointer. I think this is just a... This is not a pointer. This is a unsigned int 64. And 64. Now it makes sense. And that too, like unsigned int 64. Is he like calculating the sum of all the weights? So you're doing V18, and here you do reference V17, so that's a pointer. If V17, it's like a long. V13 is not even like who the what? It's like R10, and then you add and use that here. Literally nobody used this variable. It's a stupid variable. So confusing. Useless. So we just take the weight and you just take the weight and you put it here, and if the weight is less than V17, then just like take the maximum, take the highest weight. Core height max. And then next E, weight. This V18. Oh, no, this is minimum weight. No, like mean weight, because you want to take the shortest path. Right. Okay. And if V8, if the node info is not 0, then you would enter into a loop that will V20 plus plus take this array of pointers. No, this is array of weights. What is this? This is an array of core index times a. It's an array of pointers. To what? What is the size of it? 8, like 8 times the amount of. Is this an edge or I don't know. which is the current index of E23. If V23 is less than V21, maybe it should be. Let's try to see struct spark node. What happens if we do this? No, doesn't make sense. I think it looks worse now. What if we struct spark edge? No. What the f is this? Current index and then sus r. Or do you write? You fill this with what? And then 0. Wait. This is an array of weights. I hope that I'm right. Weight is long. Bro, why? It's long. Okay, in 64. Maybe it's like no. Like that. And sus r with node IDX main weight. Mean weight. No, I don't know. No. No, this is pointer. Stop. Connected nodes, and then we use. Maybe it's part of a structure. Maybe V12 is, where is it? One, two, three. Maybe it's like 16 bytes of that and that, like this. What happens if you struct node spark? Yeah, and then set the type. No, that looks bad. I'm losing patience. It's been already 2 hours and I don't know what is going on. So you have connected nodes. Is this really connected nodes? Yes, it's connected nodes. And then use src idx. Less than 0. Then refca. Is this ref count? I'm not sure about this, but only because I see the word ref count here, so I think this is a lock, but maybe the ref count variable can be can be locked. And then result is going to be core index, or else result is going to be still core index. Okay, and I'm going to increase core index with result plus 1, and then you set node idx is result. So this is set during finalize. How do you do this? Oh shit. Nope. Nope, shit. Okay. There it is. So. Oh. No, 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 no. This is stupid. I'm not trying those special features anymore. I don't even know how to delete this. Delete. Okay. Is deleted during traversal finalize. Right. Okay. And node info. Connected nodes. Node. Is this uninitialized heap data? I think it is. But we can't control this. Okay, let's continue. Okay, so this is where you set node IDX. Now if you go back to the query graph, and if it's less than or equal to source, or cur index is less than the destination, and return 0. And then you allocate a chunk for all the pointers. Or maybe it's not pointers. Let's see. Because like it doesn't make sense like this. Then cur index 1. Then enter a loop that will just fill the array with just fill the array Okay, I finished smoking now, so it should be easy. Let's bring the keyboard. Okay. Back an array, and then fill the array. Right. And then, how much is it in decimal? Okay. And then sus r src idx 0. And if src idx equals to dst id, I'm pretty sure we already checked it. Okay, okay, we didn't. Associate this is equal to. Then you're gonna take tst idx, and you will free this array, and you will return this, and you will return that. So this is bad flow. Like SRCI and DST should not be the same. Okay, it's not the same. So we'll go to the else. And then we'll take the connected nodes. And we point to the sus array and the SRC index. And we enter in a loop. Wow, it's a very big loop. It like starts here and ends here. While V12 is not 7FFF, which is this thing over here. The first thing you do is set -1 and then kernel, go to the next, edge, right, and then you're going to iterate. What? Yeah. Kernel next E. And then as long as next E is not equal to next E. What? What? I don't get it. So you take next E and set it to be next E prev. Okay, let's just say that, I mean, this is weird as f, but I assume that it just traverses through the edges. Okay, now here you check node IDX. This is min weight, and if min weight is not -1 to this, but it is -1 because you literally just set it to be -1. What do you mean? SRC IDX. Oh, okay, SRC. Okay, so it's not -1. It's probably 7FFFFF. Then take this useless and add the weight. Okay, so this useless is not useless. This useless is actually like, what is it? Yeah. Yeah, it makes sense. And then you put it in V18, and if min weight is bigger than V18, then you would take V18 and set it as the new min weight. Okay. Now it makes sense. So this is how you find the shortest path throughout the edges. And you're doing this every time you switch the current node with the connected node. No, let's not jump to the end. I was here. Okay, so this is how you find the minimum, and then you say cur index 1, which is part of the node descriptor. This node info, cur index. Okay. Stick V19. SRC. And then do while. Okay, this is the counter. And you take the sus array. If it's less than this and not equal to -1, then this is equals to the value of, but it's no, what? Why would you do that? If you're not using it outside of this loop, why would you do this? If V21, then you put V19. Okay, let's say that V19 is equal to, then you go here. But if it's not, then you would V19 connected nodes, like continue to the next. Yeah, continue to the next node in the connected nodes array. Then sus r v12. It's the total distance. Pointer to pointer. V12. Okay. Hmm. Mhm. Hmm. Connector nodes. What's the distance? I think this is here. But I'm not sure why. I'm not sure how to leverage that. I don't know about sus array, but I do know that next E is an edge. And that edge is free memory. So we can free that edge No, it's not. Like it is, but it's not. Okay, you can free that edge. I'm not sure if it's like, this is freed or this is freed or maybe both. Anyway, we free that and then we allocate and then we set a pointer to point to our spoofed, like our forged our forged node object. And over here we will enter an arbitrary node IDX. And as a result, we will get out of bound right. Yeah. If it's not -1, we will Right. And we'll write to this address next maybe yeah. Right. Primitive. We need to make sure that V18 will be less than the minimum weight. That's not min weight, that's no, that's total distance. Of course it's going to be bigger than min weight. Total distance is, no, it's almost 3 hours of recording. Yeah, we're not gonna have an exploit today, but we did some progress. What the fuck is sus array? Is this like, okay, if this is total distance and it's taken from here, is this distance? Distance R. Alright. It's not pointers. I thought this is pointer array because it's 8 bytes. But maybe it's 8 bytes because each element in this array is a uint. The current distance and current distance is not -1, then take V21 max distance. Yeah, because if the current distance is less than max distance, then continue to the like make max distance this and increase IDX. Take the current distance, check if it's less than max distance. If it's not, then just continue to the next, and if it is, take the distance array IDX, which is current distance, no, I'm sorry, that's the minimum distance. F02. Okay, this is max distance and min distance. Just iterate through. Find the minimum, find the lowest number in distance. And this is what it's doing, find the lowest number in distance array. And once you find it, you put it in min distance. Okay. And then if v19 this is the lowest IDX equals to this, the IDX, then go to here. This is like a bailout or something. Connected nodes, lowest IDX. This is a pointer. V24, the lowest IDX, connected nodes and distance array. And then you take the V12 total distance and the V25. This is a node. Kernel. And then you take the node and continue to the next iteration like that. So Take kernel. Mm-hmm. So this is a loop to find the minimum distance, and this is a loop to also find the minimum distance. Okay. I mean, I should have stopped earlier. I don't know why I continued. I think I'll just finish for today. Maybe tomorrow. I'm just very confused about this part and this part. Because this part, okay, I understand. It gets you the lowest distance. But it doesn't make sense that it would look for the lowest distance twice. So I don't know what this part does. I probably got it wrong. It's not getting you the minimum weight or the minimum distance. It's not. It's giving you something else. So I guess I'll figure that out tomorrow.